Last week we were going over the due dates for the labs.
Mm-hmm.
You said you could turn everything in on Monday, and then on Piazza you wrote it off.
All right, then I got it mixed up. I would like, I wouldn't, because the final grades are due on Thursday. I would prefer everything being, what do you have to turn in? Visual Mintech, Spartan, Crystal Violet, the titration.
What do we do for the Crystal Violet? It's an individual report, you said, or just
Individual, do you have your graphs, right? The Crystal Violet?
yeah.
You have your rate law, right?
Oh.
What I want is some kind of maybe thoughtful comment on your rate law. And you can take a look at your rate law and see. You could turn it in on Monday. That's okay. You guys want everything due on Monday?
Yes.
All right, then turn it on Monday. That's fine. Everything. Okay. Any other questions? The homework is due on Thursday. 24, part 2, 25, and I wanted the chemical reactions. Remember the chemical reactions homework? I wanted the chemical reactions homework. The 20 questions I handed out at the beginning of the semester. That's also due. The homework. All the homeworks are due. Okay. Any other questions? No, you don't have to turn on all your labs. You can turn those in on Monday. So just finish your homework. Do the homework. The reason I'm collecting the chemical reactions homework is the final exam is going to consist of multiple choice and I've been getting a lot of questions about the final. What exactly the final is going to cover? The final is going to cover multiple choice and chemical reactions. You have to list the driving. Yes, you do. You have to list the states, everything. You know, just like we've been doing. Everything, driving force. Yeah. That's,
So the reactions are due Thursday, not Monday?
Yes, Thursday, not Monday. Because I want to see it before the test, not after the test. Before the test. I made it the announcement I think several times at this, although it was a while ago, beginning of the semester. What else?
Are you putting down chapter 25?
Well, actually, you know what? I reviewed it, and I guess I already cut it down at the beginning of the semester when I made the homework assignment. It used to be a lot longer, the particular assignment, and a lot more involved. Some of the questions, like one in particular, took like an hour if you were to do the whole thing. And so I looked at the chapter 25. Most of those are pretty quick. They don't take much time to answer. They're pretty, I wouldn't say easy, but a lot of them are pretty straightforward. You know, don't wait until, well, I guess you're going to wait because we haven't even finished the chapter yet. All right, what else? You have questions?
For the quizzes on the gradebook, do you want us to give back those same quizzes?
Yeah, you know, the quizzes on the gradebook, if you see an error on the quiz on the gradebook, show it to me tomorrow, and then I can fix it at that time. All right. You don't have to necessarily give it back because a lot of the quizzes were group quizzes. So if I missed inputting your grade, but other members of the group have their grade in there, then just tell me who else was in your group. And so in case you don't have the actual quiz, your group partner might have the quiz. Okay. All right, what else? You guys? Uh-huh.
Have you finished grading the chapter 20 exams?
No, I haven't. I'll give those back to you this week, Wednesday. I'll input those too. I'm going to input your qualitative lab, but for those missing reports that I have, if you can just give me a list of the cations you found, and that's enough. Based on that. Okay.
For the La Chatelier principle, what are we supposed to do in our notebook? Could I just write our observations and procedure?
You don't have to write your procedure, just observations. Le Chatelier's in the notebook. Yeah, you add the HCl color lightens or something like that. I'm just looking for general observations. You did. A lot of people don't bother taking any observations. So I just want to make sure you have a bare minimum of observations. The lab notebook isn't going to be heavily scrutinized. I'm just, as long as you have the bulk of the observations in there, that's okay. As you go on, though, lab notebooks are heavily scrutinized. When you get into organic, they're looked at much more thoroughly. And as you continue on, they really check those to make sure that you've done the preliminary work, that you've taken proper observations. But it's always a good thing to do this because, everybody gets lazy. And when I was in graduate school, not just me, but other people have had to repeat experiments because our observations were so bad. You go back and you couldn't really figure out what you did. And the problem is, you're doing this ongoing research. So by the time you actually write the report, it could be like a year since you've done that actual experiment, and you go back there and try to read your notes and your observations, and you can't figure out what's going on. You have to redo the experiment. And everybody has, a lot of people have, not everybody, some people take meticulous notes. And that's really great. But a lot of people end up not taking meticulous notes and wasting a lot of time. All right. After you do it once, though, then you've learned your lesson because you don't want to do that ever again. Have to repeat an experiment. Experiments in when you go into research, experiments can take a long time. A long time to set up, weeks to set up, and then you actually do it, and then hopefully it worked out. A lot of times, they say if every experiment worked as you had planned, you'd get out of grad school in 3 years rather than the average. The average time is like 5.5 years now. Except for places like University of Illinois. University of Illinois in Champaign, if you don't finish in 4 years, they kick you out, actually. They don't want. But, when I was at grad school, I met students who've been there 10 years. 10 years, yeah, still working at it. Normally they have a time where they'll just kick you out. But, yeah. A lot of professors don't mind it because it's inexpensive labor, is what they call it. So they don't mind having help continuously around. And somebody who's experienced can teach the new people, what's going on. All right, what else? You guys got questions? All right, let's see. Let's talk about the other type. We have fusion and fission. What was fusion again? Yeah, combining smaller nuclids into bigger ones. That should be exothermic. We also have fission. Fission is taking these big ones, like U-235. U-235, neutron hits that, becomes excited, it's unstable. It's U-236, and you have fission fragments. Fission fragments, it just breaks apart, plus neutrons, and a lot of energy. Well, that might not seem like a lot of energy, 10 to the minus 11 joules. 10 to the minus 11 joules, if you tried to measure that using a coffee cup calorimeter, is it even possible? No, not even close. But you got to remember that we're talking on a different scale. This is the exact same thing when you look at quantum. When when we're dealing with quantum, there are two energies, two energy scales, and you got to flip between them, back and forth. You have the energy for a single atom, like a hydrogen atom. What's the ionization of a hydrogen atom? Well, it's only 10 to the minus 18 joules, which is 10 to the minus 18 joules is nothing, But that's just for a single hydrogen atom. And then you look at the joules per mole. If you look at joules per mole, it's over 2,000 kilojoules per mole, which is huge. Well, this is an enormous amount of energy, and so this is also looked at, for, let's see, what does it say? This is, here the sense for a single U-235 nucleus. What if you had 1 gram? Well, if you had 1 gram of U-235, how much energy can you produce from 1 gram of U-235? Now take a look at this number here, 82 million kilojoules. Well, how much water, how much coffee can you heat up with 82 million kilojoules? Enormous. And that's from 1 gram of U-235, and so that's a lot of energy. And so this is why, nuclear chemists, when we look at the most energetic reactions in chemistry, you take the most powerful oxidizer on the chart, fluorine and lithium, you're going to get about how many volts? Fluorine and lithium is going to give you about 6 volts of potential. And you convert that into kilojoules, that's a lot of kilojoules, but still nothing compared to the quantities we're talking about here. All right, and so when we're talking about U-235, thermal, what is a thermal neutron? A thermal neutron is just a room temperature neutron. If there's a neutron around, you can activate this, U-236, it splits apart into its daughter product. In the process of splitting it apart, it spits out 3 more neutrons. And so each U-235, you get